Alright, Harmony Science Academy Algebra 2, we're going to look back at inverses of exponentials and logarithms. We can turn exponentials to logarithms and logs to exponentials. So the question is when and why, right? Well, at least for this video, we should by now recognize that exponentials are easier for us to work with than logs. Logs are super different for most of us. So this skill of turning a log into an exponential is going to be very valuable to us. Okay, so we can pause the video here, give you guys a chance to copy this again, and we're going to use this skill to do or complete what you guys were asked to do on the CBA 7, which is to evaluate a log. Okay, you guys should have gotten this far, right? Log base 2 of this equals that. You should have at least been able to invert it, okay, which is probably the most valuable thing. So 2, okay. All right. Now again, after a while you kind of forget stuff, so this is what I'm encouraging you guys to do, okay? Now, once you get here, we're supposed to be free of the calculator, okay? You're supposed to ask yourself, 2 multiplied by times itself, how many times gives you 32? So some of you guys already know the answer in your head. Some of you guys have to, do some scratch work. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that means 1, 2, 3, 4, 5, okay? So 2 to the 5th equals 32. That means y equals 5, okay? All right, so we can pause, give you guys a chance to copy that down. Now 2 and 3 are going to be interesting to look at, so we'll come back to 2 and 3. Let's go ahead and look at 4, okay? All right, so we got log base 3 of 1 over 27 equals. So what do you do with these? These look intimidating. Let's make them not intimidating, okay? So we're going to go ahead and set it up. 3 base, exponent y equals 1 over 27. Again, no calculator here, so you need to have an algebra skill in your toolbox. Okay, first of all, my tip is to ask yourself, hey, this 3 multiplied how many times to itself? Gives you a 27, okay? So 3 times 3 is 9, times 3 equals 27. So I'm going to need 3 of them, okay? Now, if I put a 3 here, okay, here's the thing. I get a 27, I don't get 1 over 27. So the easy algebra trick that you guys have seen definitely in Algebra 1 is applying that negative to the exponent, and that's going to go ahead and give you the multiplicative inverse. Okay, so therefore in this case y equals negative 3. Okay, so catch that. You guys can do something like this easy. Something like this seemed impossible, but by introducing a negative in the exponent, you can simply turn it into a fraction. Why? Because 27 is the same as 27 over 1. So when you have that negative exponent, you're able to flip this fraction upside down, which flips it in this order and allows you to satisfy the evaluation process, okay? All right. So we'll give you guys a chance to copy that. Let's try this one. Or I guess let's jump to this one since these two are equal, okay? Log base 2. All right. Equals y. So notice that after a while you guys are going to get way faster. So 2 exponent y equals 1/4. Alright, so I guess I can go upwards. So first of all, 2 times itself a certain amount of times will give me 4. 2 times 2 equals 4. Okay, so I'm definitely going to have 2 to the 2 equals 1/4. However, what? Obviously this is not 4, this is 1/4. So how do I get this fraction to flip upside down? Introduce the negative to the exponent. So y equals negative 2. Okay. Make sure you circle this so we can track your work. So that's going to be probably the only surprise that now you're prepared for. This one here is pretty cool because although you forgot it, it's going to be cool to remember. We're going to have 5. What do we got? Exponent y equals 1. Okay, how do we make that happen? Well, don't forget you've got that property that any number, okay, so we'll say n to exponent 0 will always equal 1. Okay, awesome algebra property from back in the day. So we definitely have 5 to the 0 equals 1, so y equals 0 as your exponent. Okay, again, notice how easier it is to work with these exponential equations rather than logarithms. So please appreciate that big time. Okay, so when you see a logarithm, you don't freak out. You apply this skill set, okay, that we use preparing for CBA 7. So that brings us to 2 and 3. Let's go ahead and set these guys up. Okay. Again, this whole use of square and triangles only meant really for the long term. Okay, a month, 2 months from now, when you might forget this, hopefully that facilitates your recall. Okay. Anyways, 3 um, exponent y equals negative 181. Okay. So technically, our focus here is not just 81, but it's this negative. So 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. Now we know that so we can go 3 to the 4th, 1, 2, 3, 4 equals this fraction flipped over, but it's negative. Will I ever multiply enough 3's to make it negative? No. So this one would be undefined. Okay. Notice that this one is also negative, so let's um, take care of this one. Okay, you should be able already to tell it's negative, but you want to explore that. So let's go the distance here. We've got base 2 to the y equals negative 16. And how many times do I multiply 2 to get me a negative 16? Well, that's weird. Let's get the 16 first. 2, 4, 8, 16. Okay, here I don't have to worry about the fraction component. Okay, so we know how to get there. So 2 to the 4th equals 16, but the negative, how do I introduce that? I can't. So once again, we're going to have undefined. All right, appreciate your times, guys. We'll go ahead and catch you in class for some practice.